All right, thank you and good evening. Um, this is again Michael Krochik. This is episode number 2 of Angular Office Hours. This is actually going to be a relatively short episode because we're really only going to cover continuous integration and continuous deployment. This is not going to be a full pipeline demonstration. There's a lot of process discussions to have about that within your team, and I mean, not every single team is going to want the same process. In my particular case, I'm going to be using a very simple CI/CD flow built on top of GitLab, simply because GitLab comes with its own flow, it comes with its own container repository, and a whole bunch of other things that will generally simplify this particular demo. I don't have to go set up these things to move along, and since the target is Angular, the focus is Angular, we don't really want to worry about what's going on in GitLab. So the focus of this particular episode is going to be about running our tests headlessly in a meaningful way, and then generating reports that are machine parsable and meaningful to our CI/CD system. Again, this is mostly going to focus on both Protractor and on Karma. There is a little bit of noting on the linting rules, because at this point, linting is still being done and it will fail the build, but the standard output of a linting rule, something like what are good linting output formats? TS-lint output format, for instance, is by default kind of text-based. The other things you might see is check style, for instance, and so forth. These are not natively supported by GitLab, so we're just going to trust the GitLab job to exit 1 if we fail linting in some meaningful way. But there's other checks that we can make. Most of those are reporting out of both Karma and Protractor, and we're going to go ahead and do that today. The very first thing we're going to focus on is we're going to focus on the tooling. Now, I've gone ahead and created the CI project, which you can also see. It's public, gitlab.com/krochik/CI. Its sole job is to build our build container. There's not too much going on in here. There's a Docker file for Amazon Linux. I picked Amazon Linux randomly. It's a CentOS distribution. It's relatively small. It's not as opinionated about certain things as, say, Red Hat Enterprise Linux would be, or Ubuntu would be, or even just using a base Debian image. This one just happened to be something that I could easily access. This one's also one I generally use if I'm building Lambdas, because if I am installing a Node modules library that needs to be built, then using the Lambda runtime container, which is Amazon Linux, will ensure that the binary I build is actually going to work for Amazon Linux. Then I go ahead and add 2 RPM declarations, one for Google Chrome and one for Yarn, because we do want to be able to run our tests on Google Chrome, and we want to have access to the Yarn package manager. Then I go ahead and add execute the install script from, I download the RPM declaration for the node source Node 12 release. I usually only use long-term release candidates. I know that Node 13 is out. I'm only going to use 12, and then I'm going to use 14 when it enters LTS mode. I'm not going to bother using any of the intermediate versions. And then again, this is because of the long-term support contract. I don't want something to break on me suddenly, right? Because I want to focus on Angular. So I go ahead and I download this RPM, and then I just do a yum update, and I do a yum install of all the different fun little things that I need. Yarn, git, zip, unzip, make, you name it. Google Chrome stable, as it were. And then Yarn global add, I go ahead and use Yarn to install the Angular CLI, and I use it to install Nice. Nice is the command line tool for Istanbul, the code coverage tool. And we're going to get into exactly why we're installing it here once we get to actually configuring our Karma pipeline. Now, this container is built automatically via CI/CD. It is available in, where is it? It's available in the Docker repository here. You can kind of look at the pipeline and say, hey, well, what's going on here? We have this notion of Angular CI and Docker push. We go ahead and push this. up to our repository at the CI registry at GitLab. Great, we have this component available. Fantastic. Now, what do we actually do now? So what I'm going to do first is I'm going to go ahead and modify our Karma configuration file. Now, remember we had this one centralized Karma configuration file that every library would go ahead and use, okay? Now, it's not quite ready for us yet. It does have the capabilities of rolling or running headless tests, but it doesn't yet really output the kind of reports that we want for a CI/CD system. So I'm going to go ahead and make this global configuration change to these changes. And the main changes here that I'd like to call out is this addition of, first of all, the Karma JUnit reporter, and the coverage Istanbul reporters change from using what was beforehand an HTML output, and we're dumping this into this nice output directory. Now, this is a directory more or less owned by Istanbul, and which the Angular team kind of overrides to generate its own coverage reports. The reason we're dumping it into this is because there's the ability for NICE, or for Istanbul, to perform post-processing on a group of output files to generate one single report. And the reason we're doing this is because we're going to be running tests across all of our libraries. So our library, which was, VSS Forms, or sorry, not VSS Forms, our Crochick Forms directory library, and the application itself, but we're going to generate one single coverage report off of that. So this Istanbul reporter is going to dump all of its JSON output into this directory, and then we're going to perform a post-processing step to convert that into an HTML and a summary report. All right. For the purpose of report config, we're going to go ahead and modify this file for the JSON to the project name, so we have one single project, one single coverage file per project, and that they don't end up overlapping each other. So then we also have this JUnit reporter, so we're going to go ahead and dump that into the report directory, which of course we declared up here, directory named reports, and then JUnit, and then again we're going to do JUnit project name. And if you look at reports, I didn't generate that yet. Okay, fine. There's one other change I made to this. Wait, go and use the rollback command and show you exactly what that is. Karma JUnit, coverage, JUnit reporter. Actually, no, those were the only changes that I really made. So let's go ahead and run our CI test. Sorry, right? So we have ng test configuration CI. It would help if I use the correct configuration. This is going to build. It's going to take a little while. And then it's going to go ahead and output all of my test outputs to the appropriate directories that I configured. There we go. Give it a moment. There's one set of tests. There's two sets of tests, and now we're done. Now let's take a look at what this actually generated. First, it created this nice output directory, and in it are these two JSON files, one for forms and one for UI. And this is not very legible at all, and that's okay. We don't need it to be yet. And then it reports JUnit. We have, under headless Chrome, we have a JUnit report for forms. We have a JUnit report for UI. Fantastic. Even segmented by browser. That's convenient. Let me delete these old reports. There we go. Now the challenge is, how do we convert this into one single coverage report? Well, there's this post-processing step that we can then do via NICE. There we go. Where we basically say, go ahead and generate an HTML report into this directory. Now, the reason we ended up using the .nice output directory is because there doesn't really seem to be a way in the Istanbul command line to configure what directory to suck in the JSON files from. And it's fine. We can use the standard, and we can reduce the amount of stuff you have to type in to generate this report. So nice report HTML, report dir. So go and open reports HTML, index.html. Oh, look at that. Fantastic. Doesn't that look great? Here's projects form source, coverage, lib, great. Source and source app. So basically we've got all of the content come together based on all the different projects in our environment. Great. Well, that's not necessarily all we want to do. We'd also like to be able to report, so that's very human readable. We'd also like to be able to report this content to GitLab, to the GitLab CI runner. Now, it happens to know how to parse text. It doesn't do something like a Cobertura report, right? So we could do that, and then Cobertura will spit this out. Well, that's okay. But we could also do nice report equals text summary, and have basically the exact same output. Now, what GitLab will do is you provide it with a regular expression, and then it kind of figures out exactly what the coverage is. And it only really takes one value. I strongly dislike this. I know that there's more sophisticated CI/CD systems, such as, say, Jenkins, and the next generation reporting plugin for Jenkins that is able to take a Cobertura plugin, like that one, and slurp it all in and actually break things down based on it, every single one of these. But unfortunately, we have only GitLab to work with. Fine. Speaking for myself, the number that really matters is this one. One would think that statements or functions or lines or even files is important. I personally consider branch to be the most important variable here to really look at, because a branch is a statement of a logical break. It's basically an if statement. And the more of these that you have, the more likely you're going to have edge cases that are not covered, that are not handled in an appropriate way. And edge cases end up resulting in bugs. So if you can't get this one high, the other ones simply don't matter. Okay, so your goal as sort of a professional Angular developer is focus on the branch statements. And if you do this, you'll actually notice that you're going to start writing fewer if statements. You're going to be writing code that is overall more stable, because you're going to start getting into this habit of writing code that is, sane and reliably, will behave reliably. Okay, so we have nice report text summary. We have the, you know what, let me get rid of this since I keep hopping into that screen and it is not helpful. So we have nice report text summary, XML, Cobertura, fine. So now we've gone ahead and we've generated our HTML reports for our coverage. We're going to go ahead and roll that and package it so that we can keep an eye on it. And we're also outputting in a meaningful way for GitLab to be able to parse that into our code review. Great. Now on to Protractor. Now, if you remember, last time we set a Protractor to work headlessly, we did not set it up to work in a kind of a CI/CD system, right? So what we're going to do is we're going to go ahead and we're going to update Protractor with one thing. Oops, let's go here. The first change we're going to make to our global Protractor file is we're going to add a spec reporter. Sorry, this Jasmine reporters block. And it contains a JUnit XML reporter, which, as I told you, GitLab can go ahead and parse. So we're going to go ahead and configure and add that GitLab, that XML reporter. We're going to tell it where to put those reports. And then we're going to go ahead and add it to the configuration file. Great. No other changes here, except a little bit of formatting on this line. Now we are also going to want to have a continuous integration configuration of this. Much like the Karman configuration, I'm just going to copy this one, or rather I'm going to import this one. I do protractor.conf, and I usually call that protractor ci.conf. You can call it whatever you want. It's just that if you include protractor at the beginning, IntelliJ will put the pretty little icon there. And then I copy this right in. So again, I have a common configuration, and then I can import the base config.config and apply my own deltas to it. So here you can see, I know that I'm going to be running this Chrome in a container. So I have to again say it's headless, no sandbox, disable web security, disable GPU. Otherwise, Docker starts complaining and Chrome just dies. Fantastic. So here we have this. And now, last little bit, of course, we have to add the configuration to our Angular file so we can invoke it. Where's E2E? Oops. Find E2E. There's my command. There's my configurations. I'm just going to replace this block outright. CI, protractor config. We're going to use that configuration of ours. And we're not going to really change anything. There is a little bit of a nuance here. So if I want to run protractor and target it at my production environment, so that I can do like a continuous validation. So in case something breaks in one of my APIs or something like that, I like to know about that pretty quickly before my customers know, right? So what I might do is like validate and create a validate target. And here I will explicitly say dev server target equals empty string so that it doesn't try to serve up the application. And then I'm going to say, all right, well, this is going to be CI. And then I'm going to say base URL, http://ngdemo.crowdcheck.net. Fantastic, right? So if I run this now, this will run a headless set of end-to-end tests against this domain just to make sure that everything is sane. The reason I didn't really include it in this demo, and it's not actually going to be part of my CI/CD pipeline, is because I'm using GitLab Pages to roll this out. And I've discovered from some difficult learning that GitLab Pages doesn't update quickly enough for a CI/CD pipeline to validate brand new changes. So what you'll end up is you'll publish your changes to GitLab Pages, and it will have all that stuff cached in the CDN, and then you run your end-to-end tests, and you'll still be getting the CDN cache. So you can run your tests. The tests are expecting the newly deployed code, but the newly deployed code isn't there yet. So they break. Well, that's unfortunate. Well, having said that, it's still kind of a nice thing to have on occasion. If you just want to see, hey, what is broken on the application, you can just run this, say, validate, and it will just validate your production environment for you. Okay, I think I have everything. So yeah, covered protractor, covered this. Now we move on to our CI/CD pipeline. Now, GitLab has a format called GitLab CI, GitLab CI.yaml. And it's a YAML file. It has a certain markup. It's got certain reserved properties and so forth. It is very much like a Jenkins file. It's very much like a Travis file. Each one of these has slightly different semantics, but I don't really care to go into all of them. If you really care, go read up their own documentation on it for whatever CI/CD system you happen to be using. In this particular case, I have 3 stages: build, test, and deploy. I'm caching the node modules between runs. I am actually running my own CI/CD server, this old Ubuntu box of mine, so that this is stored locally and I don't constantly have to pull it from inside of the GitLab servers. I'm importing a couple of GitLab templates. One of them is a license scanning tool, a couple of jobs that are license scanning, and one that is a code quality tool. I'm not quite certain if I like these. I just kind of added them on a whim because they are sort of supported by the GitLab team itself and they recommend it. They're nice, they're cute. They don't really provide me anything useful, but might as well have it in there, right? Since, compute is cheap in my case. Oh, now, the actual process. First thing we do is, because we have a whole bunch of things that are going to depend on our libraries being there, our UI being built there, is first I'm going to go ahead and build my application. Here's our Angular CI image. I'm building it within this environment. I'm going to go ahead and run yarn install with a frozen lock file. Frozen lock file is a flag that says, install all my dependencies, but if you detect that the package file and the lock file are out of sync, throw and exit. And I like using this because it means if somebody tries to add a dependency or accidentally upgrade something without checking the lock file, you end up shaking a lot of dependency out issues out with this particular piece. And then, of course, I build my forms library, I build my app, and then I go ahead and cache it. Great. And then once I have this built, I go ahead and run all of my tests. Now these two up here, they happen to be run in the test phase as well. But in my case, again, Angular CLI, I'm depending on ngprod, and then I say, all right, ngtest configuration CI. We know about this. And then here's my nice reporter conversions. And I go ahead and I tell it to record all my JUnit reports for this one, as well as the entire reports directory, but that's kind of beside the point. Same for end-to-end for configuration CI. Again, same container, everything is the same with the exception that I say ngete configuration CI. And again, I record the results. Fantastic. Then nglint, as I mentioned at the very, very beginning, all I run is nglint. This will exit if it encounters any kind of linting errors. That is my entire sort of test phase. And then this right here is the custom deployment phase. This pages key is something specific to GitLab. In your particular environment, well, let me talk about this first, and then let me talk about alternate environments about what you might do here. Again, ng build prod, and what I do is I create the public directory. This is again a GitLab specific thing. I copy the demo application into that directory, and then I store it as an artifact. These are kind of magic keys, which again, I'm not a big fan of magic. I like things to be explicit. That will ensure that this then gets published to GitLab pages. And we can see this in action by seeing ngdemo.crowcheck.net. Here you go. This is the actual demo application built in prod and pushed from our CI/CD phase. Now there's lots and lots of different deployment models for these kinds of things. If you're using something like Angular Universal, which pre-renders things, then you're going to want to have some kind of a server on the back end that does this for you, right? In my experience, or at least the styles of applications that I have traditionally worked on, we don't need that kind of optimization. Pre-rendering your Angular pages is incredibly useful if you have an extraordinarily high traffic site. If you are really consumer focused, because we know for a fact that if you don't get your content to the consumer in 1 second or less, they're gone. Okay? So in that particular case, you want to use Angular Universal, or you want to use some form of pre-rendering, or hell, you might not even want to use Angular. But if it is an application where somebody has to log in, it's gated, and they kind of need to use it on a day-to-day basis. Things I'm thinking of are, enterprise applications, your Trellos, your Jiras, your not necessarily Facebook, because Facebook's technically a media site, but the kind of applications that you're going to log into, then you can probably cut a whole bunch of costs by uploading your files to some kind of an object store. The Amazon version is called S3. There's a free one called Minio, which is basically a container that is an S3 object store. I forget what the one on OpenStack is called, or the one on Azure, but you get the idea. And then you pick your CDN, your favorite CDN, and you stick it in front of that object store. And then you have worldwide distribution of your static assets. It is cents worth of cost. Unless, again, you're a high traffic site, in which case you're in a great space and you can probably afford it. So that kind of talks about exactly what these pages might do. This is our CI/CD pipeline. Again, we have build, test, and deploy. And this is what it looks like once it has succeeded in running. So I've got this past pipeline here. As you can see, I have here under the pages this only master flag. So I only run this when it has been merged. So here we are, ng build prod, we do our build, here's our code quality, our license scanning, end-to-end, lint, great. Let's look at our merge requests and take a look at what this crazy man called Michael decided to merge. Well, we don't have a code climate report, not certain why that's going on. Yeah, this is the linting. Sorry, this is the code quality piece. Still trying to figure that one out. License compliant detected 21 licenses for the source branch only. Well, let's take a quick look. because since this is the things you usually want to look here is standalone copyleft licenses. And basically a copyleft license is anything labeled with GPL. Because as soon as you start importing something that is GPL, you have to kind of repackage things. You have to basically license your own stuff under the GPL. So if I say import a GPL JavaScript license and I minify it and I include it, that is effectively repackaging and bundling that GPL element, and you're going to get sued. So in this particular case, we're like LGPL or MIT. Okay, that's safe. I can use the MIT, BSD3, or GPL. Fine. And a lot of these are actually fine. And the reason for that is that these are dev licenses. I haven't yet figured out how to, and I don't think it's possible with GitLab anyway, to scan only for the things that I bundle. However, what it is possible is, because in many cases you actually have to bundle the licenses with your application. So if you go into the build step, build, there we go, under options say, right, this is the library project, sorry, wrong one. There we go. Extract licenses, true, there we go. And what that will do is it'll generate a license file, which unfortunately I did not pre-generate for this, so we're just going to do ng build prod for now. This is going to generate the licenses, which will be fantastic. This is going to take a little while, so we'll look at that later. And it will go ahead and only bundle the licenses that you actually import. And then you can share that or link to it from your application and say, these are the things that I care about. But this is really good to just keep an eye on exactly what's going on. ISC, MIT, most of this stuff is safe. Okay, great. Now, as a warning, I am not a lawyer, so do not take what I just said as legal advice. If you have a legal team, go talk to them first. Great. Test summary. This is the result of our unit tests. No change in one total test, ng test, ng e2e. So it actually gives us the JUnit outputs from every single one of our jobs that reported tests, which is great. So here we have, okay, great. We have this, and I am looking for coverage. So that right there is kind of the last, that is that sort of text parsing that I mentioned earlier, and it will tell us whether or not we have increased coverage or lowered coverage in this particular PR. All right, well, I think in this case, we are pretty much ready to go. So we have all the eligible approvers. I'm just going to go ahead and approve this, start merge train, and we are done. Now when this goes, this is actually going to kick off another pipeline, and we're not going to hold it. If you are super excited about it, you can go watch it yourself. Except that it didn't merge. Go figure, right? Start. Added the merge train. All right. All right. So that is the end of this particular episode. The next episode, we're actually going to start talking about interesting things. We're going to talk about CSS variables, and we're going to talk about theming using CSS variables. We're actually going to use a UI library that makes use of CSS variables because it is one of the more advanced things in CSS that will make your life so much easier. Stay tuned for that. It will likely be sometime in the next week, and I hope you have a lovely evening.